Today I want to share a little recap of our radical unit. So far we've talked about perfect squares, simplifying, adding, subtracting, multiplying. We were just getting into rationalizing. So let's just take a look. Perfect square roots have an integer root, which means it's a whole number. Square root of 16 is 4, square root of 36 is 6, square root of 100 is 10. Then we haven't really discussed, but there are also perfect cube roots as well. Some number times itself 3 times. The cube root of 8 is 2. 2 times 2 times 2 is 8, and so on. But then we have so many other numbers that aren't perfect. So we found out that there are several things we can do. We can start off by estimating. When we're estimating, we're not giving an exact answer. We're not putting it into our calculating and getting a decimal answer. We know that it's not an integer. Well, we look at this and we know that the square root of 16 is 4 and the square root of 25 is 5. So this is approximately equal to 4. Because if you put it in the calculator, you will see that it's 4 point, and it goes on and on and on because it's an irrational number. So you, from time to time, may be asked to estimate. Another thing that we encountered was simplifying. When we're simplifying, again, there are 2 methods. You can do prime factorization, look for pairs. I prefer that you start to look for the perfect square factors. So when I look at 27, I think of that as 9 times 3. I chose those numbers because 9 is a perfect square root. Square root of 9 is 3. I get 3 radical 3. We've done some of these numbers before. We have this second one, which is the square root of 9 times the square root of 6. Square root of 9 is 3. 3 radical 6. Always check what's under that radical symbol to see if there is possibly another simplifying that can be done. But 6 is just 2 times 3, so that one's done. Now I have an existing coefficient. And remember, I'm breaking this down to perfect square factors. And if anybody wants to see the other method, just feel free to ask, and I'd be happy to spell that one out for you. Square root of 4 is 2. Now, I already had an existing coefficient, so I multiply those coefficients. And there you have your simplified version of 5 times the square root of 20. From there, we went into a discussion about multiplying. To multiply radicals, you don't need a common element here. You just multiply the coefficients, the numbers on the outside, the whole numbers, which is negative 10. And then you multiply your radicals, which gives you 24. But now you do have an additional step. You have to see if that can be simplified. And we see that this is square root of 4 times the square root of 6. And that breaks down to times 2. And my final answer is negative 20 times the square root of 6. Let's see one more of those. I have 7 times 3 is 21. 2 times 6 gives me radical 12. Once again, I want to break this down into perfect square factors if there are any. This gives me 21 times 2 times square root of 3, and I get 42 times the square root of 3. There'll be times when you do this and it can't be simplified. If for some reason I gave you the product from the product of square root of 5 times the square root of 6, well, when I multiply those together, I get the square root of 30, which cannot be simplified. Then we moved on to addition and subtraction. We want to be sure that these types of problems have the same radicand. All right, so what's under the radical symbol must be the same. I noticed back on one of the review packets that some people had a little trouble with these. In particular, when I'm looking at, say, this first example, you're taking 4 times radical 6 plus 1 more radical 6 is going to give me a 5 radical 6. Please be careful that you include that because that's 4 plus 1 more. Again, watching my signs, I see that the radical is the same, so I'll just get 5 square root of 5. But the next couple problems do not have a common radicand, so I need to first see if I can find one. Well, this is 25 times the square root of 2, so this gives me 5 square root of 2. And then this would give me 9 times 2, which is 18, which gives me 3 square root of 2. Since I have now that common element, I can go ahead and add my coefficients. Not doing anything with the radicand except being sure that it's common. I have 25 times 3, which gives me 5 square root of 3. This time I'm subtracting. I get square root of 9 times the square root of 3, which gives me 3 square root of 3. Final answer, 2 radical 3. And again, there will be times when you cannot simplify further. If you had a problem like, let's see if this one works out or not. Let me just try one more of this type. If I had something like, let's say 10 radical 50 plus 6 radical 27. Okay, so as of right now, I can't do anything with this problem. I will simplify each of these. And this gives me 10 times 5 times radical 2, which gives me 50 times the square root of 2 on this part. And then on this side, I'm going to break this down. And I see that I have 6 times 3 radical 3, which gives me 18 radical 3. This is your final answer. Why? Because they didn't come out to anything common, and I just leave it like that. That's its simplest form. On to division. I'm not sure if I touched upon this with both groups. When I'm looking at division and radicals, there's two ways that we can look at this. Since this is saying the square root of 16 divided by 25, I could also break this down to its two components and get 4/5. Let's see that again. Perfect square roots. Square root of 36 divided by the square root of 49 will give me 6/7. And again, I can break this down. Square root of 81 is 9. Square root of 16 is 4. Now, in each of those, we had perfect squares, and that was the preferred method. However, in the next grouping, I'm going to divide first and then simplify. 32 divided by 2 is 16. Square root of 16 is 4. And one last one, 50 divided by 2 is 25. The square root of 25 equals 5. So again, just learning how to work with radicals, because shortly we will be working on solving radical equations. The last thing for this review, we'll talk about rationalizing the denominator. And we would never want to leave a radical in the denominator. So we're going to use what we know about square roots, these properties, and we're going to take these and we're going to eliminate the radical in the denominator. So let's see what that looks like. We're going to get any number times itself, any radical times itself. And I think I did this already, but let's just look at this one more time. If I take a radical and square it, what does that mean? I'm going to take square root of 5 times the square root of 5, which gives me square root of 25, which ultimately comes out to a whole number integer. Let's take a look at that again. If I had the square root of 7 squared, that means I'm taking square root of 7, multiplying it by itself. That gives me the square root of 49, which equals 7. So now anytime you see this, you don't have to do all this middle work. I give you the square root of 11 squared, you know that's 11. You go right into whatever the radicand is what the answer is when you square it, because it's a perfect square root. That's what we're going to use when we're solving these problems. We're going to multiply that radical in the denominator times itself. However, whatever we do to the top, we do to the bottom, because this whole expression here is equal to 1, so it's not changing the value, it's just changing the appearance. So now I have the square root of 18 over 6. I'm going to simplify that because that's 9 times 2, so that's 3 radical 2 over 6. And then I look at my coefficient, and if I can simplify, I do. And that's done. Let's see an additional one. This one I'm going to multiply by square root of 8 in both the numerator and denominator. That automatically tells me that my denominator is going to be 8. I now have 7 square root of 16. Well, guess what? 16 is a perfect square root. Square root of 16 is 4. 4 times 7 is 28. And all I'm going to do is simplify this one more time. And that's my answer. Last one. Let's take this and multiply it by square root of 3 over square root of 3. Why? Because that's a whole number. Okay, that's going to be equal to 1. That's going to help me eliminate the radical in the denominator. And then I'm going to have a negative 3 times the square root of 15. And the only thing I notice here is that I can simplify the coefficients, and I get a negative 1 square root of 15, and done. If you have questions, we'll go over those in class. Thanks for your time.